Minimum effort, maximum marks. That's what we're going for today. If you're sitting the Cambridge IGCSE Physics 0625 exam, consider this explainer your ultimate cheat code. Seriously, we are skipping all the textbook fluff and zeroing in entirely on how the examiners actually score your paper in the measurements and units section. Because here's the reality. Knowing the physics is honestly only half the battle. Knowing exactly how to put it on the page in a way the examiner expects, that is what actually secures your grade.
It is wild how much of a difference a few seconds can make. Picture two answers containing the exact same underlying physics knowledge. The first is a painful 2 out of 10. The student writes, volume is 12, density is 2. Now obviously they know the basic idea, right? But they are absolutely bleeding marks. Now picture the 9 out of 10 answer. It says V equals 12.0 cubic centimeters, rho equals 2.4 grams per cubic centimeter to two significant figures. Think about it. It takes literally 3 extra seconds to write that second version, but that tiny adjustment catapults you straight into the top mark band.
And that completely illustrates where the easiest marks in the entire syllabus are hiding out. We're specifically targeting sections 1.3 to 1.5, so measuring length, time, volume, density, and the practical methods to actually measure them. This is the bedrock of the paper. Examiners absolutely love testing you on apparatus, experimental variables, and your table design right here in these sections. If you can lock down your technique early on with these topics, you're essentially building a fortress around your grade before you even have to look at the really complex stuff like forces or thermal effects.
But you know why ordinary brute force revision usually fails? Because you can memorize literally every single formula in the textbook, but examiners have set these highly specific, completely ruthless traps waiting for you. We're talking missing units, we're talking rounding way too early in a multi-step calculation, or giving these vague, wordy explanations instead of using precise physical terms. Students constantly mess up graph axis scales, or they suggest weak practical improvements like, oh, just do it more carefully, instead of saying, use a micrometer for greater precision. Or they write out these long conclusions that just aren't supported by their data table. This is where your hard-earned marks simply evaporate. Which leads us directly to the biggest confidence shock you can get in the exam: 0 marks. Imagine this. You spend 5 stressful minutes perfectly rearranging the density equation. You precisely substitute the mass and volume from a really complex practical setup. You flawlessly calculate the final number in your head. But you forget to write grams per cubic centimeter at the very end. Or maybe you write the wrong unit. Guess what? You will often score 0 for that final answer mark. The examiners are completely unforgiving on this. A naked number in physics is totally meaningless. In a moment, I'll show you the exact examiner clue that flips your uncertainty calculation from 0 to full marks. But first, you need the framework that makes that clue obvious. Because right now, you might be sitting there thinking, okay, cool, I'll just try really hard to remember my units. But let's be real, memory fails under exam pressure. The clock is ticking, you're stressed, you don't need a better memory, you need an automatic system. So here's that foolproof 4-step top-band answer framework. This is exactly how you need to structure literally any practical or calculation response in the 0625 exam to guarantee you hit the mark scheme requirements. Step 1 is your concept. Step 2 is evidence, or data. Step 3 is scientific reasoning. And Step 4 is examiner wording. When you force yourself to write your answers through this exact 4-step filter, it becomes mathematically impossible to leave out the tiny details that the examiner is scanning for. Let's break those down so you can actually use them. Step 1, the concept. You always start with the correct physics terminology and the equation itself. Don't just start writing random numbers. Actually write out density equals mass divided by volume. Set the stage. Then, Step 2 is evidence. This is where you substitute your apparatus values directly from the prompt or your data table. And this is absolutely crucial. You have to substitute them with their units included. Showing the examiner exactly where your numbers came from proves your method, and that secures your method marks, even if your finger slips on the calculator at the very end.
Now, building right on top of that is Step 3, scientific reasoning. This is where you justify your process. Did you spot a weird anomaly in the data? Say it. Did you use a gradient from a graph to find the average? State it clearly. Let them know how you're thinking. Finally, Step 4 is examiner wording. You have to use exam-safe language when you're talking about things like reliability and accuracy. Please, whatever you do, don't say to make it better. Instead, say to reduce percentage uncertainty, or to improve reliability by taking an average. This specific, precise vocabulary is exactly what that examiner's red pen is searching for.
Okay, I'm throwing the challenge your way to put this into practice. Listen to this heavily flawed student answer. I measured the time for a swing as 5.3, so the period is fast. I want you to pause for a second. Think about the framework we just covered and predict exactly where the student just lost their marks. There are actually multiple errors hiding right there in plain sight.
All right, let's see how you did. First up, the missing unit. 5.3 what? Hours? Milliseconds? Decades? It needs to be 5.3 seconds. Second, the wrong variable terminology. A period isn't fast. A period is a duration of time. Now, the frequency might be high, or the period might be short, but fast is a vague, everyday colloquial word. It's not a physics term. And third, the conclusion they drew is completely unsupported. It's just a vague, thrown-out statement rather than a solid, data-driven fact.
And that little exercise perfectly highlights the strict, disciplined mindset you need for this exam. Listen to this direct examiner-style feedback because you really need to internalize this. Answers must include substituted values with correct units, and conclusions must be explicitly supported by source page evidence. The examiner cannot and will not just assume you know something. You have to explicitly prove it to them on the paper, using only the data they provided to you.
So I want you to mentally screenshot this checklist. Treat this as your ultimate write-your-own-answer checkpoint. Before you even think about moving to the next question in the exam, run your answer through these exact parameters. Units. Are they actually there, and are they correct? Significant figures. Did I keep the full number in my calculator and only round at the very end? Graphs. Are my scales linear, and did I clearly draw my gradient construction lines? Uncertainty. Did I note if the result is reasonable, or did I mention a safety precaution? If you tick these boxes, your marks are safe. But here's the catch. You can use our 4-step framework flawlessly. You can memorize that checkpoint table until you dream about it. But the perfect top-band answer we built today completely falls apart if you misinterpret the specific prompt the examiner gives you. Think about it. If they say describe and you explain, or if they say evaluate and you just state, you are going to be capped at the lowest mark band, no matter how brilliant your physics knowledge is. Understanding those specific command words is the hidden factor.
And honestly, that unresolved problem is exactly why mastering the 0625 command words is your mandatory next step to securing that highest mark band. We break down the exact hidden definitions of every single command word in our next explainer, and I promise you, it changes everything about how you read an exam paper. Ask yourself, are you throwing away 20% of your grades simply because you described when you were actually asked to explain? Subscribe to our YouTube channel Ace the Exams at Ace the Exams IGCSE to excel in your Cambridge examinations. See you in the next explainer.